You are talking to a friend on a campus path. Two workers walk between you carrying a wooden door, the kind you might see on an old building under renovation. When the door clears, your friend is gone and a complete stranger is standing in her place. The stranger is already mid-sentence, finishing the exact thought your friend was voicing about taking a left at the library. More than half of the participants in the original study never noticed being handed over to a new person. This was not a magic act. It was a controlled psychology experiment with a map, a campus, and a carefully rehearsed swap. If you are already thinking I would have caught it, the evidence says you are wrong more often than you know. Understanding why is not a party trick. It rewrites what the word seeing actually means. In the late 1990s at Cornell University, psychologist Daniel Simons stood beside a large door on a campus walkway and asked pedestrians for directions. Another man was hidden behind the door, out of sight. Once a pedestrian began giving directions, two men carrying the same door crossed between them. It looked like routine construction activity. While the door moved, Simon slipped behind it and his partner stepped out in his place. The partner took over the conversation, repeated the last phrase, and continued asking for help. Participants answered and later said they had seen nothing odd. Some said the experimenter had looked slightly different, but they never questioned that he was the same person. That is not absent-mindedness. That is a precise signature of a visual system that stopped checking before the swap completed. So how does a brain lose a face it was looking at directly? The first step is that looking directly is not continuous. Your high-resolution vision is limited to a small area near the center of your retina, roughly the size of a thumbnail held at arm's length. To build a detailed scene, your eyes jump from one point to another several times a second. Between those jumps, and during blinks, the image is blurry or absent. If you strung every raw snapshot into a video, the result would be unusable. So the brain does not try. It draws up a sparse index of the scene, a person, a red jacket, a beard, a map on a table. That index is what you could describe if someone asked what you saw. It is also nothing like a photograph. Because the index is sparse, expectation fills the gaps. The brain builds a working model of the scene and treats it as the truth. Each new glance only checks a few items against the model. If the checks line up, the model stays and the world feels stable. Change blindness is what happens when something changes, but none of the checks are pointed at that part of the scene. Your eyes might have moved straight across the changed feature. Your retina recorded new pixels. But if attention is already invested in the conversation, the changed feature is never selected for comparison. You do not forget the old face. You simply never build the new face. Your experience is the model, and the model was never updated. Now consider the most common everyday version of the same trick, the movie cut. Every time a film cuts from one shot to another, the entire visual field is replaced. The camera angle changes. The lighting changes. Actors often move several feet. A glass on the table jumps sideways. If vision were literal, that would be the most jarring experience possible. Instead, it feels natural. Why? Because the edit keeps the index stable. The scene is still two people at a kitchen table, so the brain accepts the new visual field as a continuation, just seen from a different angle. Directors and editors use that acceptance constantly. Continuity errors survive because the labels matter more than the underlying pixels. Your brain does not compare frames. It compares scripts. Psychologists captured the effect in the lab with a procedure called the flicker paradigm. A picture appeared on a screen, then a gray screen, then the same picture with one detail changed. A railing was gone, a shirt changed color, an object moved. The gray screen works exactly the way the door worked. It masks the instant of the change, so the brain cannot use motion to find it. People can look straight at the changed object and still fail to notice. When they were told that something had changed, they usually said it should have been obvious. That name, change blindness, describes what follows. You are not only missing changes, you are missing the fact that you miss them. That double miss is why overconfidence about your own vision runs so deep. But change blindness has real limits, and those limits teach you something. If you are told exactly where to look, the same change jumps out at once. If identity is the part of the scene you are trying to remember, a face swap can be caught. The deciding factor is attention. Your brain sorts incoming signals into high-priority and low-priority bins. A feature that is connected to your current goal gets checked every frame. A feature outside that goal is left out of the model entirely. A pilot watching the altimeter can catch an altitude change in an instant. That same pilot might miss a different person in the cockpit doorway if their attention is locked onto a procedure. Attention is not a spotlight over the whole world. It is a narrow gate, and only what passes through it exists. Now take this same gate onto the road. Traffic researchers have a phrase for a particular kind of crash, looked but failed to see. A driver's eyes are open. They turn their head. They look directly at a gap in traffic, and then they pull out in front of another vehicle. Not every crash like this is change blindness, but many fit the pattern perfectly. The driver's brain had just finished a glance that returned an empty patch of road. Then a blink, a glance at the mirror, or the turn of the head acted as the door. When the next glance landed, a car had arrived. The model still said road clear because the change happened during a gap in visual attention. The driver was not distracted in the usual sense. They simply never built the car. The legal system carries a slower version of the same risk. A witness sees someone for 20 seconds, loses sight of them in a crowd, then points to a suspect in a lineup. During that gap, hairstyle, clothing, height, even facial hair can change. Since the witness never consciously compared the two appearances, the brain merges them into one stable identity. The witness will honestly insist that the suspect wore a blue jacket because the blue jacket was in the model. It is not a lie. It is a reconstruction. Memory research has shown again and again that witness confidence and witness accuracy are only loosely connected. Change blindness is one of the reasons. A smooth, confident model is also the model that erased the break, the seam, and the evidence that anything ever changed. Brain recordings show how deep the erasure goes. When a person consciously detects a change, a distinctive electrical response appears in the EEG about a third of a second after the new image. That response marks the moment the change enters awareness. In trials where the same person misses the change, that signature is absent. The eyes can have looked at the exact object that changed. The retina can have sent its signal upward. But the signal is never selected, never bound to the ongoing model, and never turned into a conscious event. Nothing was erased after the fact. The change was never perceptually built. Your subjective experience of not noticing is not a failure to remember. It is a failure to experience in the strictest sense. Why would evolution leave such a hole in the center of human vision? Because the alternative is worse. To notice every change, you would need to store a full-resolution copy of every scene you have ever seen, and then compare each new frame against the old one. The storage would be enormous. The processing would be too slow for real life. A hunter chasing prey through a forest cannot recheck every tree and every branch. A driver cannot watch every lane marking while also reading a street sign. The brain's solution is compression. Hold a few labels, update them only when attention demands it. That strategy is fast and useful. The cost is that whole pieces of the visible world are silently classified as background and then casually replaced without your knowledge. This is why the original door study is so unsettling. The participants were not tricked by sleight of hand. They were not embarrassed by a lapse of memory. They simply did not see what was in front of them. Their visual systems were doing exactly what they were designed to do. They kept the story going. A person is asking for directions. The door crosses the frame. A person is still asking for directions. Every label matched, so the model stood still and the world stayed continuous. The experiment did not expose a broken machine. It exposed the machine's standard way of operating. Every time you look away from a face and then look back, your brain decides whether the face is worth updating. Most of the time it assumes, correctly, that nothing changed. So what does it actually mean to see something? It means to give it enough attention to become a feature of the model, and to be ready to update that model when the feature breaks. A friend arrives with a new haircut, and you catch it in a single glance. That is not your camera being accurate. That is your brain noticing a mismatch between the old label and the new evidence. It is a tiny crack in the seam of expectation. Most of your day contains no cracks. The people sitting across from you at dinner are exactly the faces your visual system is willing to drop behind a moving door. That sounds like a flaw, but it is the price the brain pays to move quickly in a world of constant motion. Hold that thought the next time you cross a street or end a phone call and look back at the same room. Everything in front of you is not a live feed. It is a live interpretation built from small pieces of light, previous guesses, habit, and memory. Between every glance, a door is passing, even if the door is only a blink. You cannot check all of them. The question is not whether you will miss something today. The question is which things you have already decided are important enough to press your attention against. The stranger who finishes your friend's sentence is still there, waiting on the other side of the door. When you do notice her, you have done something extraordinary by your brain's standards. You have caught the model in the middle of being wrong. That is what seeing really is. Not recording, not mirroring. Paying attention to the right door at the right moment and being willing to be surprised by whoever walks through. The world is always one door away from a different story. Seeing is knowing which door to watch.